7 बजे की दिखा रहा हूँ, 1 मिनट है, मैंने अपनी स्क्रीन शेयर कर दी गुरु। ठीक है, ये मामला सेटअप है वो। ठीक है। आवाज आने दे फिर करेंगे। Hello guys, welcome to the new video again. Previously we were discussing pointers in C. So in this video we will discuss some more advanced topics in pointers. So let's start. This is a new topic, argument passing in C. So in argument passing, we pass values to call functions. So let's say this is an example of swap function and swap. So it's used for swapping two values, two variables, an integer y, and let's say this is a we define an integer temporary variable t, and what we will do, uh, we put the value of x in t. So t is x, and x we will put the value of y in x, and then all right, no, it's not like that. All right, yes, it is right, and we put value of t in y. So what here has been done? So let's say a was this in that storage like this. Wait a minute. We will, where is the pen here? Draw. All right. So when we defined these two variables a and b, so these variables acquired some space in memory, and those space we gave the name a and b, and we gave the values to those spaces 3 and 7 respectively. So a gets 3 and b gets 7. Let's say this is the uh, topology of the memory. So we call a function swap. So as we know, as we already know, when we call a function, there is a stack to contain that function, to contain the local values, local variables of that function, right? So in this stack, we function stack, we say that in this function stack of swap, we have some values. What we receive the value a and b. So we have variable x we have defined and y. This is stack only. This stack is locally for the function only, not globally here. So x get here 3 and y get 7. This is a new space for x and y. All right. So new memory, not the same as A and B. All right, we are referring to new memory places, or we can say locations, X and Y. So X has 3 now, and Y has 7. Yeah, when we swap these, and temporary variable t also on the local stack only. Let we define. So uh, when we put the value of x in t, so value of x got in t here, let's 3, and when we put value of y in x, then 7 got here, and here we get y value of t in y, and 3 y gets 3. So when the function returns, the places of x and y changed. All right, where x and y pointing to the memory locations, that memory locations swap the values, swap their values, but not the memory locations where A and B were pointing. So in the next slide, we can see here that wait a minute. In the next slide, let's see this that this is a function C function pass arguments by value. All right. This these type of function calling is call by value, not call by reference. There are two type of function call. When we call by reference, then we have pointers involved. All right. So in this, let's say this is swap function and text and y are defined for the swap function. It's- all right. So this is how it all done. So new memory locations are assigned for x and y here. So when we swap them, so 3 got 7 here and y got 7 like this. No, 3. Right. So this is how it all done. And let's say, so this is the final result of the swap function. So uh, memory locations where A and B were pointing left unchanged, but while the memory locations of x and y change, and when function returns the stack, all right, stack, what we say that I am forgetting the keyword here. Uh, I'm forgetting. Fuck. Oh, sorry. So what what we what we say that uh, move on. So in when function get return the stack for which all right for which the stack got built get we can say deleted or removed. So the x and y variables also removed because those were local to the function, not to the old program. All right. So next we say how we can do swapping by the swap function. All right. So what we do here, we to pass arguments by reference using pointers. If we pass arguments using reference by reference, then we can swap them. All right, the original location. Let's say here what we are doing here. So we are passing A and B by their reference. So we are passing the address of A and address of B. All right. So in this function, we are passing the address of A here and address of B, and so when x get what x will get in the stack, the address of x is a pointer, it will get address of A. All right. So x is equal to address of A and y is equal to address of B. So this is called by reference. This is called function called by reference. And when we define a term t, and we say t is asterisk x. Asterisk is for dereferencing here. So we are going to the address. What is the value inside the address? That value are going to be assigned for t. So t is going to get 3 here, and what is in the next, this is the first instruction, next instruction is asterisk y, x is getting the value asterisk y. So at the memory location of x, we are storing the what is the inside the memory location of y. So this is 7 itself. So b here x gets 7, and then similarly y gets 3 at the memory locations of what x were a were pointing, similarly x were pointing, and b were pointing, similarly y is also pointing. So a is pointing for 3, and it's now it gets 7, x is 7 here, and y pointing for 3, but it's get pointing for 3. Y earlier pointing for 7, but now it is pointing for 3 because we interchange the value. When we return the original, what we say is the original memory locations where value was stored for A and B are got changed. So this is in C we swap values by passing arguments by reference, or we can say passing values by reference. This is very important for pointers and value passing, I think. And see, this is how it works. X were pointing to A and Y were pointing to Y. This is clearly showing this. Alright? And when we it's going statement, so this is the final thing only. So X were pointing to 3 earlier and Y for 7. When it swapped, it's X were pointing to 7, Y was pointing to 3 only, and X is pointing to A, so 3 here, and Y pointing for 7, it got for X pointing for 7 and 3. For example, here, double V scanf left in the month for what is this? Scanf is a function. We are providing some value, get input and uh, printing it here, storing the address of this. All right, all right, all right, all right. Pointers and array. This is very fascinating topic, guys. Pointers and array. This is very correlated, go equivalently. All right. So this is very fascinating and very important for gate point of view also. So I have also made some notes. The RBR sir, and we will discuss them also, and we are going to discuss them. These are also so how pointers and array works. So this is very fascinating here. So let's say we are defining a integer array a of 100 elements. All right. How we are going to do this? This is the first element. This is second. This is third. This is fourth. All right. First element are denoted by a0 and then a1, a2, and 3, and so on. And we are defining a pointer p also. All right. We know how to define a pointer in p and c, and we are assigning address of first element. All right, of the array a to p. All right. Let's say this is first address is let's say it's 100 only. This is 100, and but we can do this format. Say p is a. This is also a. So this is not a very against what we can say. This also I mean to say. And asterisk is 58. So if we are going to we are giving the first element means where p is pointing to first element of array, address of the first element of array. We are dereferenced by the asterisk to that address, and we are then assigning to that memory location the value 58. So first memory locations of array is get 50 here, and when now there's a difference between a and pointer here. A is a constant, alright. P is variable here. We we know the definition of pointer. P is a variable which holds the value of some address. Alright. So P is a variable. Do all the operations on all the operations of P which can be done on a variable. Alright. So pointer to array first item, asterisk first array item. So asterisk p we are doing here first array item. So we are dereferencing here. This is called dereferencing. P plus 1 is pointer to second array item. So pointer to second array item, because if we say let's p is 100, if we say p plus 1 is equal to 101 and memory is byte address, but one element of get occupied 2 bytes. So let's say this is 100, this is 101, but hold the 101 byte. A B C D, this is the first element. It's, let's say, but when we say this is second element 102, but when we say 1 p plus 1 here, p was 100, p plus 1, this is to turn to 101. This is going to turn to 102 because it's to indicate a point to the next element of the memory's address. right? So this is not going to point to next memory location. It is going to point next array element. So asterisk p plus I is the I plus one element array item, and pi here is a shorthand for this. So we can, as we say I, and we can say also pi. This is pointing to I plus one element, so whatever we say, all right. Percent of xi equivalent to p plus I. So address of this, the address of this I plus one element, and as xi here is asterisk p plus I, or we can say pi here. This is called equivalent here. So this is very important, very fascinating. We can say some clues. If I hope you are getting here. Pointers can walk along arrays. What we are discussing there, guys, that pointers can walk along arrays. Like, let's say this is integer array 10 asterisk px. This is a variable x. This is array 10. This is pointer defined integer return. Pointer return p. We are assigning the first element. We can do this or and this like this, and we can go like this also. These are all equivalent, all right? And p gets the address of a0, मतलब first element, and x gets the first value of p. So x gets what is in the a gets a0, all right? A0 means first element of the array. X is now reassigning vr. So asterisk p plus 1. So this is defining for second element, and x is getting the second a1 here, and p is equal to p plus 1 is going to be p is equal to p plus 1 is p points to now a1, and p plus plus also, because we can do the variable operations on pointers, so p points to a2 now, like this. So the very important some slides here, guys, and this is where I can get this. I think where I got this is Figure overflow. I don't know, five pointers. What is the address of this file? Five pointers.pdf. I don't know where I get this PDF get from. This is very useful, but this is very important, guys. Pointers get along with arrays, work along with arrays, I'd say, and p plus plus is like, I think it's same, all right. All right. Now it's this argument is executed. All right. All right. So array names are constant pointers. This is very important. I was trying to uh, uh, tell that there is a little bit difference between pointers definition and array names. All right, they are not all similar. All right, array names are constant pointers. All right, these the variable operations can't be operated on the array names. So int, let's say a, this is a10, this is array, and p I, this is the variables integer I. P is getting first points to a0, as we discussed earlier, and a is p here. So this is illegal, because we can't assign a value, a variable, to a constant. All right, we can't change a constant. We can't change a constant here. All right, guys, we can just define that. All right, a plus plus, this is also illegal move. We can't change a pointer. If p plus we can do this. It's illegal because p is a variable. So subscripting is defined in terms of pointers. So let's say ai equivalent to asterisk a plus I, and ia also we can say this is like, all right, subscripting like this in terms of pointers. All right, so we can say this is a pointer, but it is a constant pointer only. All right, so the constant pointer. We can do some operations, but not all the operations here, right? IA, and we can say, or AI also the same, and PI also the same here. And asterisk AI is address of this A plus I. Legal and same. So what is going on, bro? Why can't we do that? And a plus plus can't illegal constant, a plus can't assign, can't we are not, yeah, this was for change, can't change a constant, but we can add something to a constant and get some new constants. All right. So a plus I, let's say is 100 and I is 10 and 110 here. So to get a new constant only. P is ampersand a0, a0. This is right. This is all about like this, ampersand of what? Asterisk of a plus 0 value. All right. Asterisk a only. So pointers can walk arrays efficiently like this, and let's say P is A here, P pointing to first element of A, and for I is equal to 0, I less than 10, I plus plus, percentage, asterisk, we are going to first P, then P plus 1, then P plus 2, and so on. Right? So let's say pointer arithmetic. This is very important, guys. What is a pointer arithmetic? This is very important for gate point of view also. What is going in live here, we can see like this. Live is going on, I think, very good here. JSK, hi, you are doing well. Dear, so great. Screen not clear. Is not clear? Why not clear? Uh, put your in timeout. Pin the comment. Pin message. And this guys. I will put user in timeout. Go to channel. Replace pin message. No, 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 no. Alright, alright, alright. Replace pin message. Hi. Reply. Can we reply him? Alright. Here goes. How many slides are left here? Not so many, but are you enjoying, guys? I hope so. You are enjoying. This is slide is very great, I think. So let's say what? How do we? So let's see. This is a what? Character array. All right. This is a um, what we say. What we say is like character array or string of character array is like this. This is the array of characters. Characteristic p. P is pointing to first element of this here, and this is long. The long is taking 4 bytes, I think, and character is C is taking 1 byte, and long is taking 4 bytes each element. So what we do here is pointer arithmetic takes into account the stride size of the value pointed to. So alright. So this is very important note to note only like this, and alright. This is size of stride, yeah, size of. So long asterisk p, p I, p plus I is increment p by I elements, not the like if we say p plus I plus p plus 2 here. So this is not going to like this. Two memory locations. This is going to jump to this is going to jump two elements on the array. So this is size of the array is 4 bytes. So 4 into 4 is 2 8. This is going to jump 8 bytes. One 4 byte and 4 byte. Now p plus 2, p plus we can say 2 here it goes for like this. Thank you so much, guys. We will meet you in the next one. We will start from here only. Thank you so much, guys. Should we end here?